Well, hello. Let's continue on with solving equations. We're going to use some of the things that you've learned in the last few lessons to take the next step. Last time you saw a lot about balancing. That was a big deal. I was trying to get you to understand that we must keep equations balanced. So keep that in mind today as we go through this lesson. Okay, so what is wrong here when Aunt Ava said she'd give Eric and Nate equal money, but she only gave Eric $5 and she gave Nate $20? I'm sure you guys know that right away, right? Is that Richie Rich over there got the 20 bucks and he's happy camper, but poor Eric only got 5 and he's not happy because they're not equal. They're not equal. One was way more. And you all know that when you lift weights, I know Kelly lifts weights, so for her, she knows that she has to keep both sides even. All right, you don't put 50 pounds on one bar, on one side of the bar, and 200 on the other. You know, you'd be like, tipping over. So that's the same idea with equations. We need to make sure that we keep them balanced at all times. So whatever we do to one side of our equation, we do to the other side of the equation. Now, our goal when we're solving an equation is a big goal to remember. Get the variable alone on one side. And we're going to play around with our equations, solving them. It's like a puzzle, trying to get that letter, that variable, all alone. So basically, a couple of steps that we're always going to look for. The first one I want you to learn today is moving the constants. We're going to move those numbers that aren't attached to a variable, all right? They're only being added or subtracted to a variable. We're going to move them to all get on one side of the equal sign. That's what we're going to start out with today. And what we'll do is we'll add, subtract using opposite operations. We'll explain that a little more in a minute. Then what we're going to do is we're going to need to get rid of any coefficients. That was part of the terms that you learned. A coefficient is a number that multiplies or divides a variable. So it's the number in front or underneath, depending on if it's multiplying or division. So let's keep going here. All right, and before we start talking about doing this stuff, answer this for me. What is the opposite operation of addition? What's the opposite of adding? Okay, hopefully you knew that the opposite of adding was subtracting. So what is the opposite of division? Okay, hopefully you also realize that the opposite of dividing is multiplying. So that's what we're going to use a lot of. We're going to be oppositional in what we're doing. Oppositional teenagers, you get in trouble for that usually, right? But here's a time you can tell your parents, Mrs. Horn said it's okay to be an oppositional teenager because I'm doing the opposite to solve the problem. All right, so here's a very simple problem. We have 14 plus x equals 12. We're going to do the first step in there. Notice I've given you that little thing in the bottom left corner from that very first slide about this. So what we're doing here is we got 14, it's being added to the x, and all of that equals 12. What can we add to 14 that'll give us 12? You can probably figure that one out in your head, right? But let me show you the techniques that you're going to need. Now, one of the things I like to do, and a lot of math teachers like to do, is just draw a line. Keep a focus on that equals. Always keep them both sides the same and always doing the same thing to both sides. So I want that x to be alone. That's my goal. I'm going to put that down here. X equals something. That's my goal. Get to that point because that's my goal. Get the variable alone on one side. Just one x equaling some number, a real number. Okay, so in order to do that, we look to see what's happening to my x. Well, x is being added to 14. So what's the opposite of adding 14? Well, we just said the opposite of addition is subtraction. So we're going to subtract 14. Now, wait a minute. If I was doing this on that scale thingy again, I would have just tipped it in one direction. Whatever you do to one side, you must do to the other side. So if we add or subtract on this side, we have to add or subtract that same amount on the other side. Keep it even. Now, what I like to do is I like to draw my equal sign, just like when you're adding or subtracting regular numbers. It's just something I like to do. So I take 14, I subtract 14, that gives me nothing, right? And then I have x equals, what is this? 12 minus 14. That is 2, but remember, the negative goes with, on the bigger number, right? So that's a minus 2, okay? So x equals negative 2. Now I wrote it down here too, but you know, that's fine. I wanted you to just visualize this is my goal. And I can double check my work too. When we get into harder ones, this is going to be real important. Plug in the negative 2 where you see the x. So it was 14 plus negative 2 equals 12. Is that true? If it's true, we did it right. Okay, if it's not, then we got to go back and check our arithmetic, check our method, figure out if we're doing it right. But 14 minus 2 is 12. So, of course, we did it right. Let's look at one more. Again, there's a number being added or subtracted to our x, and we got a number over here. So, again, like I said, until you get really used to this, maybe draw that line every time. Now, what's happening to my x? 9 is subtracting from it. So, the opposite of subtraction is addition. Add 9. And remember, it's always got to be to both sides. I like to draw my equals. If you don't like these lines, you don't have to do them, but I like it. Keeps me straight. It keeps me organized. Just like to do that. So, negative 9 plus positive 9 gives me a 0. I'm not going to write that down. I'm just going to copy down my x. So, 1x equals 24 plus 9, which is 33. Yeah, that's right. I have to think a minute. Did I do that right? I didn't whip out the calculator, but hey, check it with a calculator. Don't be afraid to use your calculators, guys. Don't be afraid. All right, here's a question for you to answer for me. Show me what you know. All right, now we're going to go on to another little technique. I don't have anything being added or subtracted to my x this time, but I am multiplying it. And again, the same idea of doing the opposite. Now, what we have here is a coefficient. Okay, that number 2 down here, all right, it's talking about eliminate the coefficients by multiplying or dividing. We're going to do the opposite. 4 is multiplying the x, so we're going to do the opposite. So I'm going to divide by 4, all right? I'm going to divide both sides by 4. And again, we can keep this line going if we want. All right, 4 divided by 4 is 1. And the x, don't do anything with it. It just is there. It's 4 divided by 4, all right? Those are the numbers we're dividing. X has to be there because we don't know what its value is just yet, but we're going to find out in a minute. 24 divided by 4 is 6. So when we do this, 1x equals 6, or we met our goal. X is alone over here. X is 6. So think about it. 4 times 6 is 24. 24 divided by 4 is 6. You can recheck yourself. But like I said before, don't be afraid to use the calculators. Okay, here's one for you to try. Now, I want to think about what's happening to my x again. Another example. This time x is being divided. Notice this is a fraction. Fractions and division are the same thing. X is being divided. So instead of dividing by 5 here, I want to multiply by 5. Okay, multiply by 5. If I multiply both sides by 5, now 5 over 1 is the same thing as 5. If I multiply both sides by 5, I will get my x all by itself. Watch this. If I rewrite this, I have 5x over 5, okay? 5 divided by 5 is 1. That gives me 1x, okay? 1x. And like I said before, I do like to keep myself organized. So there we go. I got my organization line. All right, so I've got 1x down here. What is 5 times 15? Ooh, wait, that's not just a 15. That's a negative 15. My answer is going to be negative. What is 5 times 15? You know what? I don't remember what that is off the top of my head. Out with the calculator, and it is 75. All right, so we've got 5x over 5 equals 75. We simplify this. That's why we're dividing, okay? We're multiplying. We're doing the opposite. Notice when we do the opposite, what do we get? We get 1. All right, 1x equals negative 75. Or I can rewrite it finally as x equals negative 75. Okay, you guys give this one a try. I bet you can do it really well. Now